Hello everyone, let us start with our question. In this question, what is given? A parallel plate capacitor of plate area capital A and separation is small d is charged to a potential difference of V. Now the battery is then disconnected. Okay. Now the slab of the a slab of dielectric constant K is then inserted between the plate of the capacitor so as to fill the space between the plate. Now if capital Q, E and W represent the magnitude of charge, electric field and the work on the system, we need to find whether which option would be correct. Okay, whether this or this. Okay. Now one thing we know, when we have connected the capacitor with the parallel plate through a potential difference V, what is the charge which would occur here? So Q value would be equals to what? Q value would be equals to what? C into V. Now what is the value of C? It would be epsilon A divided by D, and we can multiply it by V. So it would be epsilon A V by D. So this is charge, this is before in the initial situation. Now when we have disconnected the battery, whether the charge would change? Charge won't be changing. Why? Because charge would remain conserved. There is nothing to bring or to take the charge. So initial and final charge would remain same. So it would be epsilon A V divided by D. That means A option would be correct and B option is wrong. So this we can say that this is correct and this is wrong. Now we need to find what is the value of electric field. Okay. Now electric field, we know that electric field value after the discharging. Okay. We know that it would be V dash divided by D because we have not changed the value of the separation. It is D, and electric field is defined as the ratio of potential difference to D. Okay. Now what would be the value of the potential difference after we have inserted the dielectric? So we need to put this value. Okay. Now when after we have inserted the dielectric, we can say that C before, or we can say C into V. This is the initial situation. This is the value of charge, initial charge. That would be equals to final C into V. Now final, since we have inserted a dielectric, so final C value would be equals to K into C because it is getting K times by inserting the dielectric, and potential difference would be equals to V dash in the final situation. Okay. Now C and C would be gone. That means V dash would be equals to V divided by D. So we can just put the value. So it would be, sorry, V divided by K. V divided by K, not D. Okay. V divided by K. So what is this value? It would be equals to V divided by K into D. That means this option is also correct. Okay. This is correct. This is correct. Now what is the value of the work done? So we can calculate this also easily. How? So initially, what is the initial potential energy? Initial potential energy is what? We say that half into C into V square. And what is the value of the final potential energy? We say that it is equals to half into Kc. Why? Because capacitance in the final situation would be K times into final potential difference. Final potential difference is V dash, and we have calculated the value of V dash as V by K. So it would be V by K square simply. So we can say that it is equals to 1 divided by 2 C V square divided by K, because 1 power of K would get cancelled. So what is the change in the energy in this electrostatic energy? So UF minus UI, we find this is the change in the potential energy or electric potential energy of the capacitor. So we can take 1 divided by 2 and see V square to be common, and then it would be 1 divided by K minus 1, because it is also coming like this. It is half CV square would be common here and here. Okay. Now what is the work done? Work done is the negative of change in the potential energy. So we need to multiply this by a minus sign. So it would be half into CV square 1 minus 1 by K. This would be the work done. So let us check whether this is matching. So it is given in terms of epsilon. So we can just convert. Okay. So if we put the value of epsilon, so it would be epsilon A divided by D. Sorry, this is the value of capacitance. Okay. Now else what is there? There is 2. There is V square in the numerator, and there is 1 minus 1 divided by K. So what would be our answer? Epsilon A V square divided by 2D 1 minus 1 by K. So epsilon A V square divided by 2D 1 minus 1 by K. Okay, that means correct option are what? A option is the correct option, C option is the correct option, and D option is the correct option. So hope you have understood this explanation. Thank you. Hello everyone, let us start with our question. In this question, what is been asked? A parallel plate capacitor is charged and the charging battery is then disconnected. Now if the plate of the capacitor are moved further apart by means of insulating hand, okay, it is moved apart by means of insulating hand. So we need to tell whether charge increases or voltage increases or capacitance increases or electrostatic energy increases. We need to tell this. Okay. Now, for example, this is one of the plate. We are just drawing. This is one of the plate. Okay. Now, what is the charge? and let's assume that this is another plate. Now, what we are doing, we are disconnecting the battery. That means the charge which has come here, for example, plus Q, the charge which has come here, for example, minus Q, this charge would be same. Okay, because charge would remains conserved. So if there is no external source to increase or decrease the charge, so the charge would remain same. That means charge on the capacitor increases. This is wrong. Okay, A statement is wrong. Now, potential voltage across battery increases and capacitance increases. So first of all, we should write about the capacitance. So capacitance is written as what? So C equals to, we can write C equals to epsilon A divided by D. Okay. Now, if the separation is increasing, D is increasing. If D is increasing, then capacitance is what? Capacitance is decreasing. So capacitance is decreasing. This is wrong. Okay. Now, what to tell about the voltage? So voltage is written as what? V equals to, we know that V is equals to what? Q divided by C. Now we know that C is decreasing, so this is decreasing. So this is inversely proportional. Q is constant. Q is constant. So these are inversely proportional. So if C decreases, then V would increase. So we say that voltage across capacitor increases. This is correct. Now, electrostatic energy stored in the capacitor increases. We need to find this. So how is electrostatic energy written? It is written as U equals to 1 divided by 2 Q square divided by C. It is written like this. Now, if C is decreasing, now this factor is decreasing, so it is inversely proportional to C because Q is constant. So that means U would increase. So that means this option is also correct. So what are correct option? B option is the correct option and D option is the correct option in this case. So hope you have understood this explanation. Thank you.
Hello everyone. So we are given with a question which says a parallel plate air capacitor is connected to a battery. So it is an air capacitor. So medium is air between the two plates. The quantity of charge, voltage, electric field, uh, and energy associated with the capacitor is Q naught, V naught, E naught, and U naught respectively. Now a dielectric slab is introduced to fill the space between the plate with battery still in connection. So the corresponding quantity now become Q, V, E, and U. So we need to relate Q, V, E, and U with Q naught, V naught, E naught, and U naught. So let's begin. First, initially the capacitor of air capacitor is connected with a battery, and after that also when a dielectric slab is introduced, battery is been connected. So we can say V will be equals to V naught. All right. Since we can give a reason over here, since battery was connected in both cases. All right. So from here we can clearly say that voltage remains same. So V equals to V naught. So this option straight away gets means it is incorrect statement option. So let's move further. As we introduce the dielectric in it, so we know that its capacitance value will get altered, and we can write the capacitance after the means introducing dielectric becomes C naught into K. All right. If K is the dielectric constant of that slab. All right. So from here, initially we know the formula for charge, that is Q is equals to CV, and in terms of when the it is the charge developed when the dielectric is being introduced, and this will be the formula when Q naught equals to C naught V naught when there was no dielectric. So from here we have developed the relation, so we can write instead of C here, we can write C naught K into V. Alright, so since V and V naught are both same as from the equation above, we can write this equation as Q is equals to uh, K times of Q naught. Alright, so from here we can clearly see the value of Q is greater than the value of Q naught. Alright, so and here we will give the reason since V is equals to V naught. So option A is the correct option. Now let's move further and try to check all the options given. Also we know the electric field. Now we have to develop the relation between electric field. We know uh, potential is equals to ED. From here we can write potential upon D can be written as E. So what we can write over here is, since V is constant and plate distance between plate is constant, so we can say E is equals to E naught. Here we can give a reason, since again V equals to V naught, since both the quantities are same and D cannot change, that is the distance between the plate of a capacitor is D. So the capacitor is same, so the distance will remain unchanged, so E equals to E naught. So this option is also an incorrect option. Finally we have to check about the energy. So about energy we can say energy can be written as, in terms of when the dielectric slab is introduced, its energy become half CV square, and initially it was U naught is equals to half C naught V naught square. Alright, now again, instead of C we can write C naught K, that is C naught K V. Again we can write V instead of V naught square. So from here we can see U can be written as half, and it would be C naught CV square can be written as half CV square, can be written as U naught, so it becomes K U naught. So from here we can say the value of U is greater than U naught. Again, since V equals to V naught, the same reasoning will be there over here. We can say this because we know, since we will write since the value of K is greater than 1, because value of K is equals to 1 for the air, and when a dielectric slab is introduced, so the value of K for any dielectric slab other than air is greater than 1. So I hope you have understood the concept, and the option D is also a correct option to this question. So thank you for watching.